Today we'll do questions related to the logic gates. Yesterday I explained this topic. Figure 11.1 shows a symbol for a logic gate and its truth table. State the name of this logic gate. What's the name of this logic gate? For which the output is by the product of the two inputs. What we call this gate? A and B are the input and the final output is there. What's the name of this gate? The first one?
Not.
Not or and?
And sorry, and.
Yeah. For the second part, what is this gate? What's the name of this gate?
Nor.
This is not, that's right, because this one is or, but there is circle at the end. So actually it's an inverter, nor. Now, use the use the screen annotation to complete the output here. Or I will ask 0 and 0. What will be the output? So because it's we get by addition for OR gate we add, and because it's an inverter, so it will be invert. So 0 0 it is 0, but inverter it will be 1. Then 1 0 it's 1, inverter make it 0. 0 1 also 1, make it 0. 1 1 is 1, that's make 0. Yeah, the first one is 1 and the rest are 0. Figure 11.3 shows a system of a logic gate used to ensure the security of the strong room in the bank. A strong room door will not open when the output F is 1. Complete the table to show a logic gate state A, B, C, D, E when the strong room can be opened. You need output F to be 1. So we need output F to be 1. Example, if I took this as 1, 1, what will be output D? So if I took A as 1, B as 1, so output D will be, the output D will be 1. So output D is 1, that is the input for F. And what should be the input C? What should be the input C? Input C should be 0, because if C is 0, when it passes through inverter, the output will be 1, because I need these two to be 1 so that the final output will be 1. Is it clear, this part? Because in the question, we want the output of F to be 1. We want this to be 1. So if you want F to be 1, because this is AND gate, so both inputs should be 1. So we want D to be 1. We want E also to be 1. How E is the output of C. So C should be 0. So inverter, it will make it 1. And this is AND gate. So A and B should be 1. So D will be 1. State the name of a logic gate with a truth table shown in table 9.1. This logic gate, this truth table is for which logic gate? So this one, if input is 0, output is 1. If input is 1, output is 0. So this is for NOT gate. Because NOT gate is having one input and one output. Figure 9.2 shows a digital circuit. Complete the truth table in table 9.2 for the circuit for all possible combination of the inputs. So this is OR gate. This one is AND gate. And this one is NAND gate. If we want C to be 1, what should be A and B? So it can be 1, 1, or because we want C to be 1, D to be 1. So both should be 1, 1, or if we want C to be 1, then it can be 1 and 0, because if 1 and 0, the output D will be 0, or it can be 0 and 1, or both will be 0. So what will be the output E? If A is 1, like C is 1, D is 1. C is 1, D is 1. NAND gate is there. So what will be the output? So 1, 1, output of AND is 1, but because it's a NAND, so it will be 0. If it is 1, 0, what will be the output of NAND? If it's 1 and 0, the output of AND will be 0, but because it's a NAND, so it will make it 1. Again, it is 1, 0, so output of AND will be 0, but this will make it 1 again. 0, 0, it will be 0 for AND, but output of inverter, so it will also make it 1. Figure 10.1 shows the faces of the two ammeters. One has analog display, another one is digital display. What is meant by the term analog and digital? So what's the difference between analog and digital? Analog means the quantity which shows a continuous variation. But you cannot write analog means not digital. It's not the right way to define anything. So analog means the quantity which shows a continuous variation, which is having two state or shows discontinuous change or variation. Or you can also write discrete is a right word as well, which also means discontinuous. Yeah, the same difference. Look, you can see what happened. Say if a voltage, example, originally it was 0 volts. Then the voltage changes to 3.2, example, or 3. So how the voltage will change to 3? Like it will start with 0, then 0.1, 2, 3, to 1, 1.5, 2, 2.5, and eventually it will reach 3. So this shows a continuous change. To reach that point, you will have all the numbers. But the digital meter, the moment you connect directly, it will show you the number. So if you have a digital meter, what will happen? Like example, if we say the current changes to 3.2 ampere or 3.1 ampere, so directly the number, you will get that number. So discontinuous change will be there. But when you have a continuous change, you call that as analog. If there is a discontinuous change, we call that as a digital. Is it clear the difference between analog and digital? The reason why they give you a displayed counters as well, analog display and digital display, so you can write the answer using this display. In a space below, draw a symbol for AND gate. So for AND gate, we have symbols similar like D. The input will be there, input and output. If the question they say describe the action of AND gate with two inputs, so basically you can draw a truth table here. So we have input, input, and output. AND gate to get the result, the final is by multiplication. So if it is 0, 0, what will be the result? That will be 0, 1, 0. It will be 0 because AND gate is by multiplication. 1 multiplied by 0, you will get 0. 0, 1. So you will get 0. And 1, 1. The final will be 1. So this is how you describe the action of AND gate. In a space below, draw a circuit symbol for NOT gate. So we have to draw a circuit symbol for NOT gate. Label the input and output as well. So this one is input and output. State the action of a NOT gate. So if they ask state the action, you can mention if input is high, output will be low. If input is low, the output will be high. Or you can draw a truth table as well. Both are acceptable. So if input is low, the output will be high. And if input is high, the output will be. You can also draw a truth table for this. In a space below, draw a circuit symbol for NOR gate. So we have to draw a circuit symbol for NOR gate. NOR gate means combination of OR and NOT. Input, this one is also input, and the final output will be there. Describe the action of a NOR gate in terms of input and output. So you can describe in words or you can draw a truth table. So if I draw a truth table for the action of a NOR gate, so we have input, input, and the final output will be there. So for NOR gate 0, 0, what will be the output for a NOR? So 0, 0 is 0. It should be 1 for, because it passes through inverter. 1, 0, what will be the output? So it will be 1 for OR, but passes through inverter, it make it 0. 0, 1, it will be 1 for OR with inverter 0. 1, 1 is 1, but passes through inverter, it will make it 0. Or you can mention, you can explain this in your own words as well. You can mention if both inputs are low, the output will be high. If either one of the input is low or both inputs are high, the output will be low. In the question, a chemical process requires a heating at low pressure to work correctly. Like there's a chemical reaction, so we want the chemical process, it required heating at a low pressure. We want the pressure to be low to work correctly. When the heater is working, the output of a temperature sensor is high. When the pressure is low, the temperature pressure sensor has low output. Both output are fed into a NOR gate. A high output from a gate switch on the indicator lamp. Explain why indicator lamp is off when the process is working correctly. So what is the meaning here? Like we have a temperature sensor, okay, and we have a pressure sensor. They mention here when the heater is working, the output of a temperature sensor is high. So output of a temperature sensor is high when the heater is working. So that's one. When the pressure is low, if the pressure is low, the pressure sensor output is also low. So if there is a low pressure, the output of a pressure sensor is, and when heater is work, the output of a temperature sensor is high. And what they did, both of the output fed into a NOR gate. So we have a NOR gate, and both of these output are fed into a NOR gate and then showing an indicator lamp. So both outputs are fed into a NOR gate. A high output from a gate switch on the indicator lamp, because 1 0 it will be 0, but inverter, sorry, 1 0, 1 0 is 1 for OR gate, but passes through inverter. What it make? It makes 0. So the question is why the indicator lamp is off when the process is working correctly. The process is working correctly, like the heater is switched on when the temperature is high and the pressure sensor is reading a low pressure. The process is working, but the indicator lamp is off. Well, why the indicator lamp is off? Because one of the input is high. That's why the indicator lamp is. Yeah, so you can mention the pressure is low, so the output is low, or you can mention one of the input is high for OR gate, because NOR gate basically it works when both inputs are low, then only it will work. But here one of the input is high and another one is low. That's why it is off. Now in the next question they're asking, state whether the lamp is on or off in the following situation. The pressure is low and heater stop working. Pressure is low and the heater stop working. If heater stop working, it means the temperature sensor is giving a 0. If heater is working, the temperature sensor is 1. What will happen to the indicator lamp? It will be off or on? So 0 0, it is 0 for NOR, 0 for OR, but passes through inverter, so it will be 1. So the indicator lamp will be on. The heater is working, but the pressure rises. So heater is working means this is 1, pressure rises, this also 1. What will be the output? So output will be 0, or we can say 0 means the lamp will be off. In a space below, draw a NOT gate. So you have to learn the circuit symbol. So draw the circuit symbol for NOT. for this circuit, you have to complete a truth table. Figure 10.2 shows a digital circuit, which is having AND gate and OR gate. Use the screen annotation to complete this table. First, complete the output C and then the output E. And the output E, keep in mind this is OR gate, so this will be 0. Yeah. This will be 1. If C and D are, this will be 0. Yeah, so because 0 0, that's 0 1 0 1 0 1 0 1 1 1. The second one is the first one is AND gate because it's resemble with D, and the second one is simple OR gate. So this was 0 0 0 0 0 0 1 1, and 0 0 it was 0 1 0 1 0 0 1 1 0 0 0 1 0 again. Sorry, it will be 1 1 0 1 1 1 1 will be there. Now what they did, suggest a modification to the circuit to produce the output Z, means the input D, till input D is there, and then the output Z is. So what change is done to the circuit? Like compare the two tables with the circuit. The question is what modification is done. You can see this is the original circuit. Like first there was an AND gate, and then we have OR gate. Now what they did, they change something in the circuit. So now the output is Z. Instead of E, the output is Z. So the question is what modification is done to this circuit? Can you identify the modification done to the circuit comparing the two tables? Yeah, so basically what happened, the last OR gate, this OR gate is replaced by AND gate. So both of them are AND, because you can see A and B 0 0, the output C they did not add there, but this will be 0, and the output Z is 0 0 0 0, and output Z is again 0. Output Z is 1 when both inputs are high. So it means that what they did, what modification is done to the circuit, that the OR gate is replaced by AND gate. So initially there was a OR gate, but now it is replaced by AND gate. You have to just recognize from the outputs, like you can see first you have to compare these two tables. This was 0 0 1 1 1, sorry, this was 0 0 0 1 and 1. But when you was checking this part, C and D, because it initially it was OR gate, so if one of the input is high, the output was high. But now what happened? You can see the output D, the output Z is only high if both inputs are high. A and B are high, so output is 1, and 1 and 1, it will be 1. So it's just easy to remember both inputs are high, that's why the output is high. So if you remember the final outputs of the gates, you can compare this. Describe how a digital signal differ from analog signal. In the beginning, we just discussed. You may draw a diagram. So you can draw that analog and digital meters. The quantity, the meters, the sensors, which shows a continuous variation are known as analog, and which shows a discrete variation or discontinuous variation is known as digital. In the appropriate box, draw the circuit symbol. So AND gate, the circuit symbol D will be there, and OR gate, this is for OR, and label the inputs and output, and state how the behavior of AND gate differ from OR gate. So you will mention when both inputs are high, the output will be high for AND, but for OR gate, if one of the input is high, the output will be high. This is about digital and analog. Those who joined late, analog signals, how they differ from digital. So digital analog means the quantity, which shows a continuous variation. What is the meaning of a continuous variation? There was example, a meter was given. So example, it's written 0, 1, 2, 3, 4, and 5. So for example, if it's an ammeter and the current is 3 ampere, so how this meter will show a reading? It will start with 0 and it will move continuously until it reach 3 and it will stop. So this is a continuous variation. We call that as analog. But what is the meaning of digital? Digital displays or counters. So if you have a digital meter and it shows 3 ampere, so how it will represent 3 ampere? Like if this was a dot here, so how it represent 3 ampere? The moment you connect, directly it will give you the value. So if a display or a meter directly shows, no, you will write a standard definition. You will mention the one which shows a continuous variation, not with arrows or pointer. You mention a quantity, a meter which shows a continuous variation is known as analog, and the quantity which shows a discontinuous variation is known as digital. Yes, for asking for difference, the quantity, the signals which shows a continuous variation. And if you want to show a digital and analog signals, you can also represent by waves. So in terms of waves also, we can represent. This is continuously like the value is changing. This is called continuous variation. But for discontinuous variation, A digital signal, means digital signal means two states. Either it is on or it will be off, or it will be on or off. Only two states are there. That's known as a digital. This is a digital signal. Only two states are there, high or low, or on and off. But here it's on and it can have different values. So we call that as analog. An arrangement of a logic gate A, B, and C is shown in figure 9.1. The arrangement has two inputs, X and Y, and two outputs, P and Q. The output P of a logic gate B has a logic 1. So output P, which is of logic gate B, this is having a logic 1, means high. Determine the logic state of the two inputs for B. What will be the two inputs here? If I want, this is, which gate is this? First identify which gate is B. What is B? And, or, nor, NAND. So B is a NOR gate. And I want the final output to be 1 for a NOR gate. So what will be the inputs? So both inputs, no, if it is 1, if both inputs are 1, 1, 1 will be 1 for OR, but inverter will make it 0. So it cannot be 1. So it will be 0. So this will be 0. This should also be 0. So this 0 means the Y should. So upper input, determine the logic state of the two inputs of logic gate B. So upper input should be 0 and lower input should also be 0. In the next part, state and explain the logic state of output Q. So logic state of output Q. So it's up to you, like the you have to just complete this. So how you will complete, because it's a continuation of the question, the output of output P of a logic gate B is equals to high. So this one is already high. So it means this one is Y. So Y is 0. So this Y is going to logic gate B as well, and this Y is going to logic gate C as well, which is also a NOR gate. What about X? This is NAND gate. So X, both inputs are there, like X is the same input is there. We want the final output to be 0. If we want final output to be 0, what could be X? Example, if X is 0. So if X is 0, this will be 0 and 0. 0, 0 for AND gate is 0, but passes through inverter, so it will be 1. So it means X cannot be 0. If X is 1, this whole X is going to, as a first input, as a second input as well. So 1, 1. For AND gate, it is 1, but passes through inverter, it will make it 0. So for this one, because they mention the output P of a logic gate B, we want output P of a logic gate B has 1. So we want this to be 1. So if this we want to be 1, the upper input should be 0 and the lower input should also be 0. Is it okay now? Or still lagging? Is it audible now? Now it's clear. Is it audible now? So basically, the output of a logic gate B has a logic 1. So if output is logic 1, it means because it's a NOR gate, so both inputs should be 0. So this 0 is actually Y is 0. That, but what about X? Because this is a NAND gate. NAND gate, the inverter NAND gate is there, not with AND. So if I want the final output to be 0. So if this was X, if I take X as 0, so this first input is 0 and second 0 0 is 0 for AND, passes through inverter, so it should be 1. So it means X cannot be 0, X should be 1, because when I take X is equals to 1, this will be 1 and 1. 1 1 is 1 for AND, but passes through inverter, it will make it 0. So X is 1, so this 1 is there, and Y is 0, so this 0 is going there. 1 and 0 passing through a NOR gate, so 0 and 1, it's 1 for all, but passes through inverter, it will make it 0. So how you'll explain this all? You will mention when X is 1 and Y is 0, the output Q will be 0. Is it clear? Because we have to state logic state of Q. So logic state of Q will be 0. In a space below, draw a symbol for OR gate. So you have to draw the circuit symbol for the OR gate. Label the inputs and output. Then describe the action of OR gate that has two inputs. So you can mention if both inputs are 0, the output will be 0. If one of the input is high, the output will be high. Or if both inputs are high, the output will be high. Or instead, you can also draw a truth table and mention inputs and output. So if both inputs are 0, the output will be 0. If one of the input is high, the output will be high. If both inputs are high, the output will be high as well. So in the space below, draw a NOR gate. So a NOR gate label the inputs and output. In the question, they ask state whether the output of a NOR gate will be high or on or low or off when one input is high and one is low. If one is high and one is low, what will be the output of a NOR gate? So it will be off, or you can also say 0. If both inputs are high, so if both inputs are high for NOR gate, 1 it's 1 for OR, but passes through inverter, it will make it 0. So it will be 0. This is NOR gate. So for NOR gate, because we get the result by addition, so 1 is 1, but passes through inverter, that makes it 0. In the next question, figure 9.1 shows a digital circuit made from 3 NOT gates and 1 NAND gate. So complete the boxes. Output, you can use the screen annotation to complete the boxes. Three NOT gates are there and 1 NAND gate is there. You can write 0, you can write low or high. So if this one is high, this will be low. And if this one is low, this will be high. Then passes through NAND gate. 1 0, it will be 1 0 for AND. Passes through inverter, it will make it 1 or high. And then passes through inverter, that will make it low. In the question, state the effect on the output changing both the inputs. Means if they change both the input, will it affect the output? Like this one was initially high and they made it low. And this one is low, we made it high. Will it affect the final result? So no change will be there. This will be 1, this will be 0, this will be 1 0, it's 0, make it 1, and passes through inverter, it will be 0. So the final, you will mention no effect or no change on the final output. Figure 10.1 shows an AND gate with 2 inputs and 1 output. State the output when A is high and B is low. 1 and 0. So for AND gate, it's by multiplication. This will be 0. When both A and B are low, so the output will, if A is low, B is low, output will also be low. Okay, in the question, an electrical thermometer in a greenhouse gives a low output if a temperature is too low. A humidity sensor in the same greenhouse gives a high output in the greenhouse give a high output if the humidity in the greenhouse is too high. The alarm sound when both the temperature is too low and humidity is too high. Complete the diagram to show how a NOT gate and AND gate may be used to provide the required output for the alarm. So a thermometer, because what condition we want the alarm to work, an alarm sound when the temperature is too low and humidity is too high. So humidity sensor we need 1 and temperature sensor we need 0. And we have two gates, we have NOT gate and we have AND gate. So how we can connect? So if I connect a NOT gate here first, and then AND gate, no, not NAND gate. It's not a NAND gate. It is separate because they mentioned complete a diagram to show how NOT gate. So you have NOT gate and AND gate. So NOT gate is separate and AND gate is separate. NAND gate is a different thing. If you connect a NAND gate here, what will happen? Like example, if you can connected a NAND gate here, if temperature is too low, humidity sensor is high, 101, it is 0, passes through inverter, it make it 1, alarm will work. But the thing is, for example, if humidity is also too low, so if humidity is too low, so for NAND gate 00, it is 0 for AND, but passes through inverter, it will also work. So means if you connect a NAND gate, it will work at different condition as well, not your desired condition. It will work at different condition when, but you want it to work when the temperature is too low and the humidity is too high, and you have to connect a NOT gate and AND gate, not a NAND gate. NAND gate is one component, but NOT gate and AND gate are two different components. So 0 will make it 1, 1. So 1, 1, it will be 1, and alarm will work at only desired condition. If you put a NOT gate for humidity, humidity is already high. Temperature, because I mentioned a temperature is too low, so this is 0. Humidity is high, so 1. If you connect a NOT gate before the humidity sensor, means after the humidity sensor, so 1, it will make it 0. So both inputs are 0, so output will be 0. Alarm will be off, but you want the alarm to sound like you want alarm to be 1 when temperature is too low and humidity is too high. So if you connect other way around, it will not be correct, because you want your circuit to work at a desired condition when the temperature is too low and the humidity is too high. Then this is actually related to the part which we already drew. Use your diagram, use either high or low to indicate the level of input and output when the alarm sounds. So you just have to mention low. So this was low. You can mention 0. This one is high. So 0, it will be 1, or high. High, the final will be 1, so it will be on. Figure 10.1 shows a symbol of a logic gate. State the name of this logic gate. What's the name of this? Yeah, that's right. It's OR gate. And label input and output. So this one is input, input, and output. In a space below, draw a NAND gate. So you have to draw a NAND gate. NAND gate is a combination of NOT and AND. Always label the input and output. Inputs are there and output. How to know the difference between NOR gate and OR gate? If there was a circle, it means it's a NOR gate. Without a circle, it's only OR gate. Okay, so that was the last question related to the logic gates. Next week, I will complete this circuit component part. So I'll end this session. Any question related to logic gates? And from next week, inshallah, we'll have a regular class timing as well as the duration.